Hello everyone, my name is Alpa Rupala and I am the instructor for your subject, that is Python for Data Science. So today we are going to learn about the base topic, that is conditioning the data. In the conditioning the data, we are learning about the subtopic, that is missing values. So what is the missing value, how we can deal with the missing value, that will be our main concept, and then after we will move forward that how we can drop the missing value data or how we can replace the value with the some another value of your missing value. Topic, that is dealing with the missing value. Now what is the missing value? Basically we can see that when we are providing a data or when we are getting a data from the user, at that time some information cannot be provided by the user. So this information can be called as a missing value. So for an example, if I can say that suppose we are having a customer record, and in this customer record at the time of fetching that data, the customer has not provided the age. Suppose some of the customer is providing the age and some of the customer is not providing the age. And if we want to check for the analysis, likewise, suppose we want to have the analysis of the customer in which area group they are purchasing which company product more. So like this kind of analysis, when the missing value is the age itself, we cannot perform this kind of analysis. So the missing value is very crucial one. And the missing value is very important in the areas like machine learning and data mining. So the missing value can also be referred as a NA, that is not available. Next, in pandas, the missing value is represented by two values. The first one is none. The none is a Python singleton object. Second one is NaN, that is the acronym for not a number. It is also a special kind of floating point value. This can be accessed using the numpy module. Next, that is imputing the missing value. The word imputing means that we are going to fill up whatever is required in your missing value concept. So this can be, first of all, we can use the dropping of your missing value rows and column using the drop nm method, and secondly we can replace our missing value using the replace method. So let us just go for a practical for detailed understanding of this. So here we are in our Jupyter notebook. So first of all, checking for the missing value using is null concept. So our first topic of your missing value is that how you can identify that this particular row or column is containing the missing value. So for that we can use two methods, that is null method and not null method. So the is null method is returning a data frame of a boolean value which is having the true value for your none or NaN value or your missing value. So suppose for an example we are developing one dictionary with the value A of the column, and this all are the value in which we are having the none value over here, none value over here and none value over here. So we are creating a data frame by this dictionary that is under our def variable. Now we are checking that the def value is containing the null value or not. At whatever place it is containing the null value, that will be returned as a boolean data frame true value, and all the else value will be false. So let us just run this code. So here it is, this is our data frame, actual data frame with the values, and here it is we are having the NaN value. So at whatever place we are having the NaN value, at that place we are having the value true by the is null method, and every other place it is containing the false value. Same as we can use another method, that is not null method. So you can check it is totally contradict to the previous one. So it will have the false value at whatever place it is having the null value, and every other place it will have the true value. So by this we can identify that our data is containing, if all the values are true, if we are using the not null, then this is what our data is not having any missing value. But if any of the value is false, then our data is containing the missing value. Next, how we can drop our missing value data. So for that we can use the drop NA method. So here is the syntax of your drop NA method. This is the method of your data frame. So data frame object dot drop NA. It is having three attributes: axis, how, and in place. So the axis value is a boolean is a value with the two values only, integer values, that is 0 and 1. So it contains the 0 if we are assuming everything according to row. It will have 1 when we are assuming everything according to the column. So if we want to drop the row at that time, we must need to use the x is equals to 0, and if we want to drop the column at that time, we must need to use the x is equals to 1. By default, the axis value is 0. Now next attribute is how attribute. The how attribute is containing two values, that is any and all value. By default the value is any. So what is the concept of any? If any of the value is none, at that time it will drop a whole row or column. For all, if all the values is none, only that time it will drop the row or column. So this is the difference between the any and all. Next one is in place. This in place value is a boolean value. It is exactly the same which we have learned previously many times, that is in place, if the value is equals to true, then it will change or update your data frame itself, but the in place value is equals to false, then it will return the updated data frame. So let us just check this all fundamental by practical. So this is what our dictionary data with this none and none two places value. Now we are using the drop NA to our data frame df.drop NA x is equals to 0. That means all our fundamental will be according to the row. How is equals to any and in place equals to false. So obviously it will return what? New data frame. So let us just run it. So we can see that we are having in our second, third and fourth row the NON in data, that is none data, right? And we are using the x is equals to 0. So all the rows which is containing the missing value will be dropped, okay, according to our any how. But suppose if we are using 1, so all the columns with the missing value will be dropped and only C will be represented as output because it is not containing any missing value. Now suppose this is any we have used and by default it is also any, but suppose if we want to check for the all one, so this is my concept in all. I am changing my data in which I am providing my data value as none for all the values. Okay, and over here I am not having any none value. Okay. So this is the value in which all the columns is containing proper value, no missing value is present. In this only single missing value is present, and in this column all the values are missing value. So we are applying this all fundamental on a column. How is equals to all? That means only those column will be deleted who is having all the values as a missing value. Okay, so let us just check it. Okay, so A and B will be returned as an output and C will be deleted because it is containing all the values as a missing value. But suppose if we are using any, at that time B and C both will be deleted. Okay, because the B is also containing a single value as a missing value. Even though a single value is contained by your column as a missing value, then that value will be dropped. That column will be dropped. So this was the concept of your drop NA. Now the next concept, okay, this is also of a drop NA, that we are reading our CSV file and creating our data frame. Now we are using the drop NA function of our data frame with the access 0 and how is equals to NA. So let us just run this code in which we are just providing the length of your original data frame, and after the dropping what will be the length of your new data frame and the difference between that. So this is our actual data. Okay, over here we are having the null value and over here also we are having the none value. So this two rows must be deleted in your new data frame. So this is here with the row index 0, okay, and this is the row index 4. So this two data must be deleted. Yes, it is deleted. 0 and 4 is deleted. So the previously in a old data frame the length was 13 and in a new data frame the length is 11. So total difference is of 2. Now imputing the missing value by replace function. So this is the replace function by which you can use the missing value. So the replace function is having this much of attribute: to underscore replace, value, in place, limit and method. So this to underscore replace will contain none, value is none, in place is equals to by default false, limit is equals to none and method is equals to ffill, that is forward filling method. So this to underscore replace can have any string, list, dictionary, series, integer value, float value or none value then it can also contain the regular expression, and whatever value you want to fill in place of this any of the value that will be under the value attribute. Now the in place is a boolean attribute as we have discussed. Then limit is the maximum size number of consecutive values to forward or backward fill. Now it must be have the value greater than 0. Now what is this limit that we will discuss in a programming itself, and method that also we will discuss in a programming. So first of all, we are providing or we are creating one series with the value 0, 2, 3, 4 and 5. Okay, now we are using the replace method. So we are going to replace the first attribute, that is a 0 in our series. The 0 data will be replaced by 6. So this is the output. The 0 is replaced by 6. Same as we can also create a data frame. Now at whatever place in a value you are containing the 0, that all will be replaced by 5. So here you can see that over here it were having 0 and over here it were having 0. So this is 5 and this is again 5. Now next we can also apply on our data frame full series can be updated. So this full series is containing the value 0, 2, 3 and 4 or sub portion of your series that is in a sequence 0, 2, 3 and 4, and that we are going to replace by the value 5. So this is the value 5. Okay, now suppose you want this is the same value which is being replaced. You can also provide as a value whole list, but this must be equals to whatever the number we are providing for a replacement. So here we are providing 4 numbers, so exactly 4 numbers must be given. Either one is given or either exactly same number must be given, but not more than or less than that number. So here for 0 it will replace by 4, for 2 it will replace by 3, for 3 it will replace it by 2 and for 4 it will be replaced by 1. So let us just run this code. So you can check that this is 4, 3, 2, 1. Okay, so your data is updated. Now the method, that is ffill. Okay, this is forward fill method. Now we are providing the values which must be replaced, that is 2, 3, 4 and 5 as a list in a replace method. Okay, but we are using, okay, let us just remove this limit first. So this is the output. So our data for which our replacement were required with the method, that is ffill, that is forward fill. So whatever number sequence we have given before that, whichever the value is present, next value of the missing value or replaced value will be filled according to it. So like in our previously the data were 2, 3, 4 and 5 which is to be replaced, and before that we are having the value 1. So all this our value will be replaced by this 1. So we are having all the values will be replaced which is replaced by 1. So this is all. Now suppose if we are using the backward fill, so in a backward filled, after 4 we are having the value what? Sorry, after 5 we are having a value what? 6. So all the data will be filled according to the 6. So from 2, 3, 4 and 5 is filled by 6. So this is the forward fill and backward fill. Now the limit. So the limit must be greater than 0. So we are providing suppose the value by 2. So that means only 2 consecutive value we can replace. So in a backward fill only 2 consecutive value we can replace. So you can see that from 6 we are replacing. The request for the replacing is what? 2, 3, 4 and 5. But it will only replace 4 and 5 because we are limiting the value by 2. Okay, let us just take one more example. Suppose we are using 3 and we are using the forward fill. So according to it, what data must be replaced? That must be replaced 2, 3, 4 and 5. But with the forward fill method, as we have discussed, it will replace all the values of from here to here by 1 because we are using the forward fill. But we are limiting our consecutive number to be replaced by 3. So only 1, 2 and 3. This much of data will be replaced and this will be as it is. Let us just run this code. So this is the output. Now next we can also give or provide that what number at what in your whole data frame what number must be replaced by which number or value using the dictionary. So in a replace method we are giving a whole dictionary where whatever the number which is to be replaced that is given as a key and replacing value will be given as a value of your dictionary. So we are replacing our 0 by 20 and our 1 by 80. So this is 0 value which is replaced and this is 1 value which is replaced. Same as in a dictionary. Now you can see we have not defined that this 0 will be of the column X or column Y. But suppose if we want to specify that only the column X 0 value must be replaced and column Y 1 value must be replaced. If we are specifying like this, then at that time we must need to use in a dictionary that in a X column 0 and in a Y column 6 must be replaced by the value 18. So this is the output in X data and in a Y data. In a X, wherever we are having the value 0, that will be replaced by 80, and wherever we are having the value 6, it will be replaced by 80. Now same in X column only, we want to replace two values, that is 0 must be replaced by 100 and 3 must be replaced by 200. So the syntax of it is like this. So in X, this is the 0th value which is replaced by 100 and this is the third value which is replaced by 200. So we are having the multiple variation of your replace method with dictionary also, by which you can specify that at what column, at what value, a specific value you want to replace. Now the next one is you can also use the replace method with the to_replace attribute. Now in this one we can specify a particular value from your data set. So let us just check for it once. So this is your original CSV file. We are reading our content in our data frame. Okay, now we are using for our data frame the replace method with the to_replace. At wherever we are finding the Gilbert, we want to replace it by the value New York. Okay, and the in place value is equals to true. That means our original data will be updated. So this is the city in which we are having the Gilbert over here and Gilbert over here at the location 5 and at the location 9 and at the location 11. So that will be replaced by 5, okay, 9 and 11 by New York. But if you want to replace more than one value, so for replacing more than one value, we can provide our multiple values in a list. Okay, so this is the list and this is the value. So we are replacing Gilbert and Phoenix by the value New York. So here the output. So at whatever place we were having the Gilbert and Phoenix. So you can check 4 and 5. Okay, this 9 and 11. It all will be replaced by New York. 4 and 5, 9 and 11. So this is about your to underscore replace, where it is finding the specific value and replacing it. Now this to underscore replace value can also be used with the regular expression. So we can also provide a regular expression in your to underscore replace, and the whatever the value we are using in a value that will be replaced when this regular expression is being satisfied. So as we are using over here the regular expression, so the attribute must be true. So now as we can see that we are starting with the BI, and it can have the last value, the third character can be float. So we can check that over here we are having the BI. Okay, after that it is having the I and it is having D. So at two places it is satisfying, then the length is equals to 3, and this is the exactly 3 values. And over here also the length is equals to 5. Although it is starting with BI, but the length is not being satisfied. So only at these two places it will change the value. So this is the output. It at only two places it is changing the value. Now suppose if you are having the NaN value in your data set, so for that suppose if we are having the none value, so we are taking the NP, that is numpy variable, that is np dot nan, and then after we are replacing that value with the value given provided in a value attribute. Now the next one is imputing the missing value by interpolate method. So here it is the interpolate method. So in an interpolate method, one by one we are checking it. So interpolate method is having a lot of attributes, that is a method. So first of all, the method can be a linear method, time method, index method, value method. This can be a cubic method, quadratic method, polynomial method. This is all kind of your mathematical interpolation methods. The axis value is 0 for the index and 1 for the column. The limit value is none by default, but it must be what, greater than 0 for a consecutive replacement. Now the in place value is a boolean one. This can have a true or false, and the limit underscore direction value can have two values, that is forward and backward or both. So we can see that over here we are having the data frame A, B, C, D. Now we are using the interpolate method with the value linear. Now we are limiting our direction with the forward. Okay, so we can check that what is according to output. Okay, so this is having the NN value over here, NN value over here, here, here and here. Okay, now we are using the interpolate method. So in an interpolate method, all the values will be replaced by forward values. So this method, this value is 3. Okay, so it will be replaced by your forward value. So according to this 5 and 1, it will calculate the linearity and it will replace it. Now this is not having the forward value, so before this NaN it doesn't contain any value, so it will be taken as NaN itself. Now this is having the forward value, that is 3.0, so it will be taken as a linearity as it is. Now it is also containing the NaN value, before that any another value 16, so it will be replaced by the linearity. Now over here also it will replace the value. Now if I am limiting the value, that is the limit is equals to 1. So we can see that only one value will be replaced, another value will be taken as it is. There won't be any change because we are limiting the value. So this is the forward method. Limit direction attribute value is forward. Now we can also use the limit direction value as backward. So the backward value will be taken for an analysis. So this NaN will not be replaced. Now this time this NaN will be replaced, but this one cannot be replaced. So this is the output. So this NaN is not replaced, but all the another NaN according to the forward filling can be replaced. And it can also limit the value. So from this to this value will be calculated, but this won't. So let us just run this one with the limiting value. So we are limiting the value. So according to the backward, this will be filled, but this is NaN. We can also change our interpolation method. Suppose we are using the zero method, so no linearity can be calculated. Okay, and this is our output according to the zero method. So this is all which we can use in our statistical analysis. Thank you.